How's it going again, ladies and gentlemen? Mr. Ron here, looking at 12.4 net ionic equation. So what we want to be able to do is we want to be able to balance half reactions to give us our net ionic equation. Just to clarify, remember net means like overall ionic equation. So it's not going to have no spectator ion, no spectators, right? That's not anything that's actually involved. It's the same before and after, so our net reaction isn't going to involve that. In order to do that, we want to make sure that the electrons lost are equal to the electrons gained. Right? You can't gain more electrons than you lose, and if you lose them, they got to go somewhere. So net ion equations, balancing them is kind of like what we do with charges for a compound. We got to make sure that the electrons cancel out, and we're going to do that by making multiples of half reactions. So say, for example, where's my pen at? Let's say I had Mg that was plus 2, and I had Cl minus 1. Well, I know I'm going to need 2 of those to cancel out one of those Mgs. And we're going to do kind of the same thing, but with the whole half reaction. If we had, we'll just get to an example, all right? So let's say we had these 2 half reactions. We had copper being oxidized by losing 2 electrons, become plus 2 charge. And we have silver plus 1 gaining an electron to become silver 0. Well, if copper's losing 2 electrons, something else needs to be gaining 2 electrons, but Ag only gains 1 electron at a time. All right, so that means that this reaction, the reduction reaction, is going to have to happen twice. We're going to have that happen twice. Right, so basically just distribute that 2. And instead of 1 silver gaining 1 electron, giving me 1 silver atom, we're going to have 2 silver ions gaining 2 electrons total, giving us 2 silver atoms. Now I have a total of 2 electrons being lost and 2 electrons being gained. So that's where those electrons went. Electrons were lost by copper, and they were given to that 2Ag+. All right, so now we can add these together, and the electrons should cancel out. I'll show you what I mean. So here's our oxidation half reaction. Here's 2 of our reduction half reactions. So if we were to combine those, you would see, all right, well, let me draw a little math thing. Remember, the arrow is like an equal sign. Well, I have 2 electrons on the left and 2 electrons on the right, so they're going to cancel each other out. Add up what's left, and it's just 1 Cu, 0, plus 2 Ag plus 1s, becomes a Cu plus 2 ion, and 2 Ag zeros. So that's all we're doing. Things to check. Does the Cu on the left equal Cu on the right? Yep, I got 1 Cu on the left, 1 Cu on the right. 1 Ag, or 2 Ags on the left, right? I got the 2 over here. Why can't I ever find my pen? 2 Ags here, and then 2 Ags there. So that's all good. Other things to check for. The charge on each side. Well, let's think about this. I got a copper that has a 0 charge, and I have 2 plus 1s. So I have a positive 2 on the left, and I have 1 plus 2 on the right, and 2 zeros. So I have plus 2 on the right. So the charges are balanced too. So everything checks out. So let's do a little practice. Feel free to pause it here and try it before going forward. The first thing we want to do is be able to figure out what's the charge of each thing. Li by itself is 0. Zinc over here by itself is 0. Zinc can only be plus 2. Nitrate, the whole thing, is minus 1. Again, over here, each nitrate is minus 1. Lithium has to be plus 1. So the question is, well, what was oxidized? Well, it was lithium. Lithium was oxidized. It was Li0, and it became Li plus 1 by losing 1 electron. All right, well, what was reduced? Zinc. Zinc went from plus 2, and it became zinc 0 by gaining 2 electrons. So now I got to go, all right, well, how do I get these to combine so that the electrons cancel out? If I'm gaining 2 electrons, I have to lose 2 electrons. So I must double this top reaction. I need 2 Li0, give me 2 Li plus 1, and 2 electrons. So now the electrons are going to cancel each other out. We got 2 on the left, 2 on the right, and I add them all up. So I got 2 Li0 plus a zinc plus 2 ion, becoming 2 Li positive 1 and 1 zinc 0. So let me check. All 2 Li, 2 Li, 1 zinc, 1 zinc. overall charge over here would be positive 2. All right, I got 2 zeros and a plus 2. Here I got 2 plus 1, so it's positive 2 and a 0. So positive 2 equals positive 2. Good to go. Just did it. All right, let's do another one. All right, 2K, which is, K is by itself, so it's 0. Cl2, just chlorine, it's 0. Becomes K, has to be positive 1, and chloride has to be minus 1. All right, well, what was oxidized? The K went from 0 to plus 1. And it did that by losing 1 electron. Now, the chlorine is one of those pesky guys that starts off as a Brinkelhoff. So it's Cl2,0. So you got to start as Cl2,0. And it has to become 2 chloride ions. Well, how did it do that? Well, each chlorine went from 0 to minus 1, and there's 2 of them. So they have to gain a total of 2 electrons. Now, this one can be kind of easy to look, so just like the last one. If I'm gaining 2 electrons, I must lose 2 electrons. So I must do that oxidation half reaction twice. So there we go. Now the 2 electrons being gained on the left cancel out the 2 electrons being lost on the right. Now you add them up together. I got 2K, 0, and a Cl2, 0, giving me 2K plus 1s and 2 chloride minus 1s. So now I can check. All right, well, I got 2K on the left, 2K on the right, 2 chlorines on the left, and 2 chlorides on the right. So that's good. So now let me check charge. Well, on the left side, I got 0 overall, and on the right side, I got positive 2, and I got minus 2. So that gives me 0 overall over there too. So that's done. I think we'll do one more, right? And then we're going to skip. We're going to do this one. This is a more difficult one. This is going to be our last one. All right. So we got tin chloride. So I got to figure out, well, what's the charges of all this? Well, I know chloride's got to be minus 1. There's 2 of them. So tin must be plus 2. Now here we got iron. We got chloride. Chloride's got to be minus 1. And there's 3 of them. So iron must be plus 3. Now over here, tin with 4 chlorides, each minus 1. Tin must be positive 4. And iron with 2 chlorides, each minus 1, must be a positive 2 charge. So now the question is, well, what went up in charge? And it was the tin. The tin went from Sn plus 2 to become Sn plus 4. How did it do that? Well, to go from 2 to 4, that's a difference of 2 electrons. So it had to lose 2 electrons. Now, the thing being reduced, what went down in charge? Well, it was the iron. The iron went from Fe plus 3, and it became Fe plus 2. How do you go from 3 to 2? You got to gain 1 electron. So now we got to figure out, how do we get the electrons to cancel out? If tin's losing 2 electrons, each iron's getting 1 electron, we're going to have to do something about that. We're going to have to double the irons. So 2Fe plus 3 will gain a total of 2 electrons. You give us 2Fe plus 2. Now the electrons lost is equal to the electrons gained, and they cancel out. We add it up. So I have Sn plus 2 and 2 iron plus 3s becomes an Sn plus 4 and 2 iron plus 2s. So now let's check. We got 1 tin, 2 Fe's, 2 Fe's. I got to figure out the charge. I got a 2, I got 2 positive 3s. So that's a 6. It adds up to be a total of a positive 8 on the left side. Now here I got a positive 4 and 2 positive 2s. So they're going to add up to be positive 8 as well. So everything checks out. That's all you're doing with the half reactions. Making sure the electrons lost are equal to the electrons gained. Maybe I'll show you a trick in class. Ask me about it. See you then. Bring questions.